Okay, so let us start the tutorial. So in this case, we'll discuss the tutorial for chapter 0. First, let us start with the concept review. So the first question is to ask the distance between x and 7 on the real line is 3. What is the possible value of x? Okay, so I will copy the question in the whiteboard, and then I will discuss the solution. Okay, so concept review part 1A. So the distance between x and 7 here on the real line is 3. So the question is, what is the possible value of x? Okay. So here we will do it in the two ways. First, we write it as the distance between x and 7 is the absolute value of x minus 7 equals to 3. Here we know that there are two possibilities, so we can say that x minus 7 equals to 3. So it is equivalent to x minus 7 equals to 3, or x minus 7 equals to minus 3. So here x minus 7 equals to 3, I have x equals to 10, and x minus 7 equals to minus 3, I have x equals to 7 minus 3 is 4. So the possible value of x is 10 or 4. We can do it geometrically as follows. So on the real line, I'll put 7 here, and then the distance between the number x and 7 is 3. So I move, let's say 7, 3 units to the right, and then I get 10 here. Okay, this is 1x, and then I can move from 7, 3 units to the left, 6, 5, 4. So I get 4 here. Okay, so it's possible to have 4 and 10 as the solution. Okay, so now let us consider 1b. So in 1b, the question is to solve the inequality absolute value of x plus 3 is less than 1. Okay, so in this case, I will see here part B. The question is to ask the solution set to the inequality, and the inequality is absolute value of x plus 3 is less than 1 is. Okay, so the question is to ask this. So we start with absolute value of x plus 3 is less than 1 and is equivalent to x plus 3 is in between minus 1 and 1. And here I after separating by 3, I have minus 4 is less than x, and then it's less than 1 minus 3 is minus 2. Okay, so the solution set is a set of a point x for which x is in between minus 4 and minus 2. Okay, and of course we can rewrite this as in the interval notation, minus 4 comma minus 2 here. Okay, so this is one way to solve this inequality. Another method is that we see that the interpretation of absolute value of x plus 3 as we can rewrite verse absolute value of x plus 3 equals to absolute value of x minus 3 there. Okay, and the interpretation is that on the real line, okay, I will put minus 3. Okay, and then here I have the inequality is less than 1. The meaning is that the distance between x and minus 3 is less than 1. Okay, so first I will move from minus 3 1 unit to the right. I will obtain minus 2, and then 1 unit to the left I obtain minus 4. So you see that the distance now between minus 4 and minus 3 is 1, and similarly the distance between minus 3 and minus 2 is also 1. So if the distance is less than 1, so the solution set will be in this region. Okay, solution set will be the set of a number between minus 4 and minus 2. Okay, or simply just write it as the interval, open interval minus 4 comma minus 2. Okay, okay, I hope that it is clear. Now let us try to continue to the another question. So for the next question will be, okay, this is just to write the set of real number, subset of real number into the interval notation. Okay, more precisely, I will write it as follows. So the set of okay, so the set, okay, x is real number where x is in between minus 1 and 2, included minus 1, is written in the interval notation as follows. Okay, write it as interval notation minus 1 comma 2 here. Okay, so you'll see that I will use the square bracket here to indicate x is included to be equals to minus 1. Okay, and then we have the usual or round bracket here to indicate that x is less than 2. Okay, so x is not equals to 2. Okay, right. Now let us continue. 1D here. Okay, so for 1D, we need to recall the definition of the odd and even function, 1D and 1E. Okay, okay, especially let us start with 1D. So 1D, if the graph of an odd function let's say pass through the point, no, what is the point? Minus 2 comma 10, then it pass through what is point from this. Okay, so here so let us recall what is the definition of the odd function. The function f is called an odd function if f of minus x equals to minus f of x. Okay, okay, so this is the definition of the odd function. Now let us see, let's say the function in the question is f as well. So here I have f minus 2 equals to 10, right? Okay, so here if I replace x by 2, then I will have, okay, put x equals to 2. Then I'll have in the definition f minus 2 equals to minus f2. And of course here this implies f2 equals to minus f minus 2, and that will be minus 10. Okay, so the answer will be, if the graph of the function, okay, so here x, this is y, so f minus 2 equals to 10 there, f2 will be minus 10, so I will write it as 2 comma minus 10. Okay, so geometrically the odd function, the graph of the odd function is symmetric with respect to the origin, the point 0 comma 0. Okay, okay, so in other words, I can obtain the graph of the one part of the graph of the odd function by taking the reflection of another part, and then actually reflection with respect to the point 0 comma 0. Okay, okay, so that's the uh, meaning of the odd function. So let us continue for 1e. For 1e is actually we have the even function. Okay, okay, so the question is, if f is an even function, let's say with the formula f of x equals to square root of x for negative x, then f minus 1, what is the value of f minus 1? Okay, so that's the question. Okay, so let us first recall what is the meaning of the even function. So f is even if f minus x equals to f of x. Okay, you can think the example of this is like x squared or minus x squared. So geometrically, the graph of even function is symmetric with respect to the y-axis. Okay, so this is the even function. Okay, so and then in this case, if I want to find f minus 1, then I need to find f minus 1 by using the definition of the even function equals to f1. Okay, and in this case, simply because 1 is greater than or equal greater than 0, then we will use this definition. So in this case, I will have square root of 1, and that will be 1. Okay. Okay, I hope that it's clear up to this point. Now let us consider number f and g. Okay, so number f, we have the graph of the function, and then we want to know what is the intersection of the graph of this function with the x-axis and the y-axis. Okay, so here is the detail. F. So in this case, the graph of the function fx equals to, let's say, x squared multiplied by x plus 1 divided by x minus 2 here. So here the graph intersect the x-axis and the y-axis at a certain point. So the idea here, first, if we want to find the intersection with the y-axis, let us put x equals to 0 here to the function f of x. So substituting x equals to 0, I have f0 equals to 0 squared multiplied by 0 plus 1 divided by 0 minus 2. So in this case, I will have f0 equals to 0. So in this case, I say that the graph intersect the y-axis at 0, 0. Okay? The graph of f intersects the y-axis at 0, 0. Okay. Okay. So that's the intersection to the y-axis. To obtain the intersection with the x-axis, then I should find the solution of the equation x squared multiplied by x plus 1 divided by x minus 2 equals to 0. So in this case, okay, find x such that f of x equals to 0. Okay? Now that f of x equals to x squared multiplied by x plus 1 divided by x minus 2. And in this case, this equals to 0. And the solution to this one will be x equals to 0, of course, x squared equals to 0, x equals to 0, or x plus 1 equals to 0, or this in this case, x minus 1. Okay, so the conclusion to this one, the graph of f intersects the x-axis at the point 0, 0 and the point minus 1, 0. Okay. Okay, so that's for one, where is it? Number 1f. Okay. Actually, you can take, you can type the formula for the graph of the function in online software or plot online, then you'll get the shape of the function there. Okay. Okay. So apparently, it's not that difficult to see it. Now, for 1g, 1g, we have the graph of f, and then we want to obtain the graph of f of x plus 2. Okay, so it's actually just translation here. So the graph of fx plus 2 is obtained or can be obtained by translating the graph of f of x. Okay, so here you have the graph of f of x, and then what is the graph of fx plus 2? Okay, we call that, if we write in this way, then the graph of f of x should be translated to units, to the left, right, to units to the left. Okay. Okay. Yes. Now we continue to the last part of number 1 concept review, 1H. Okay. 1H. Here I have, suppose that I obtain the angle between the positive x-axis and the graph of fx equals to 2x. And then that's the angle is denoted by theta. Then I want to know what is the tangent of theta. Okay. It's actually, it's better to draw the graph first. Yeah, x and y axis. Then we draw the line here, 1, 2, 3, 4. Let's say 1, 2, 3, for example. Okay, so here is the, oh, okay, -1, -1, -2. Okay, so here is the line. First, okay. Should do it carefully. Perhaps it's not so suitable. Okay, so let us say that this is the line, and then I want to know the angle between the line and the x-axis. Positive x-axis is theta. So tangent theta actually is just a ratio of y over x0. Okay, okay, assuming that or delta y divided by delta x. Okay, so if I have x here, then I have y here. So if I take a look at this triangle, there's the triangle here, then I have tangent theta equals to y over x. And then I know that y equals to 2x, 2x over x, and that will be 2. Yeah, the tangent theta is 2. Okay, so that's for concept review. Now let us continue to the number 2. So number 2, the question is, given two real numbers, we want to know what is the example of a real number between these two numbers. Okay, okay, let us start with 2a here. Okay, 2a, I have two numbers, 1 over 100 and 1 over 99. Okay, so we want to know what is the number in between these two numbers. Okay, so suppose that we just take a common denominator here, then I will have 99 over 9900 here, and Also, I have 100 over 9900. Okay, so in this case, okay, so let us double it. Okay, so multiply the denominator by 2 and numerator as well. I have 0.08198 there. Okay, similarly, I have here 198 there, and in this case I have 200 800 there. Okay, so in between, of course, we have 199 over 19,800 there. Yeah, so that's the answer. Of course, it's not the unique answer here. Of course, we may find other real number. Yeah, and in particular, in this case, it's we obtain a rational number. Okay, but of course, this is not exactly how to obtain this. This is not the only way to obtain a real number between two uh, real number. As we can see in part B here, we have two numbers. The first one is square root of 2. The second one is 1.41. Okay, so the problem with this is that square root of 2 is not a rational number. Yeah, so that's why we cannot uh, do we cannot solve it with the previous method. Okay, so to see this, so in general, if we have two real number, to construct the number between these two number, then we may take the average between these two number. Okay, so here is the theory. Suppose that we have two real number, A and B. Okay, of course, there is an order between A and B. So either A is less than B or B. Okay, so A, B with A is not equals to B. Then we have A is less than B or A is greater than B. Okay, so in this case, let us take the average between these two. The average between A and B is the average of A and B is A plus B over 2. Okay, so in this case, if I consider this one, A is less than B. So if A is less than B, then A plus B over 2. So since A is less than B is less than B plus B over 2, and that will be B. Okay, so A plus B is less than B. Sorry, A plus B over 2 is less than B, and A plus B over 2. Okay, now we'll see that B is greater than A. So have A plus A over 2, and that will be A. Okay, so in this case, I will have A plus B over 2 is less than B, and A plus B over 2 is greater than A. So in the conclusion will be A plus B over 2 is always in between A and B. Okay, so that's how we construct two real number between two different real number. Okay. Of course, the case A is greater than B is similar. I just interchange the role of A and B, do it with the same argument. Okay, so now let us take A equals to square root of 2 and B equals to 1.41. Okay, and then a plus b over 2 should be square root of 2 plus 1.41 over 2. Okay, so that's the two numbers between a and b. Okay, okay, now yeah, actually this is also real number, but of course we cannot simplify it because we square root of 2 is not the rational number. Yeah. Okay, so let us continue for number 3. So in number 3 we have to check whether the given statement is correct or not. Okay, is true or false. Okay, so let us start with 3a. 3a. Here I have the following statement. If x is less than 1, then 5x minus 1 is less than 10. Yeah, less than 10. This is actually correct because if x is less than 1, then 5x minus 1 is less than 5 minus 1, and that will be 4. And 4 is obviously is less than 10. Okay, so this statement is correct. Yes, correct. Okay. So now let us consider the second question. For 3b, if I have, let's say, x is less than 1, then x squared is less than 1 as well. Okay, okay, so the question is not correct because if or taking or let x equals to, let's say, minus 2, let's say, then x is less than 1, obviously minus 2 is less than 1, and what about x squared equals to minus 2 squared equals to 4 is greater than, yeah, makes this, that's not correct. And what is the conclusion? Therefore, this statement is not correct, or this statement is not true, is false. Okay, so you will see that although, let's say, x squared less than 1 implies for implies x is in between -1 and 1, but here you'll see that it's only x less than 1. Okay, so the counterexample naturally should be a number less than -1. Yeah, and then obviously we may take x equals to -2 there. Okay, so that's 3b. So let us continue for 3c. So 3c, the question is, there exists, to check the whether this statement is true or false. There exists a real number x such that x squared equals to 0.1. Yeah. So there exists a real number x such that x is squared equals to 0.1. Okay, so in this case, because it's only as the existence of the real number, then we just provided an example. Okay. Okay, so in this case, let us x equals to square root of 10 divided by 10, then x squared equals to square root of 10 divided by 10 squared. That would be 10 over 100. It will be 1 over 10. Okay. And that will be 0.1. Okay. So the conclusion for this is that this statement is true. There exists a real number such that its square is 0.1. Okay. All right. Now let us continue. For 3D, the statement will be for every little number x, for every real number x, there exists a real number y such that y is greater than x squared plus 1. There exists a real number y such that x squared plus 1 is less than y. Okay, that's the statement. Now you'll see that because we have for every real number here, for every, then we may not take an example of x. So we need to verify this statement for every x. Okay? Of course, we cannot check it one by one. So the idea is that if you see the second part of the statement, there exists a real number y such that x squared plus 1 is less than y. So y depends on the number x. Okay, actually, we need to know what is the choice of y. Okay, so given x, we want to define y such that y is greater than x squared plus 1. So in this case, y should be greater than x squared plus 1. Of course, obviously, if we are given x, given a real number x, then simply define y equals to x squared plus 2. Then y equals to x squared plus 2 rather than x squared plus 1. Okay, so simply here I have y equals to x squared plus 2 greater than x squared plus 1. So in this case, okay, this statement is correct. Okay, so this statement is true. Okay. Okay. And now let us continue to the last part of number 3. So number 3 here, there exists, yeah, 3e, there exists real number y such that for every real number x, yeah, we have the same one, y greater than x squared plus 1. So be careful with the order of the statement here. Although we have the same inequality here, y equals greater than x squared plus 1, but it appears that there exists y appear first in the sentence, such that for every x. So here you will see that y appear first, came first, and then x. But of course, this is only the existence of y, and we have for every x here. Okay, so we cannot say that x depends on y here because y is already chosen. Is already chosen. Then for every x, yeah. So x is actually is independent of y, yeah. But this is impossible because if okay, we cannot actually we can find this existence of y because if we are given y, then okay, so let us consider in this case and showing that this statement is false. So if y is negative, then I should have if y is negative, then y is less than 0. But obviously, x squared plus 1 is greater than 0. Yeah, so the statement is not true for negative y. And if I consider positive y or non-negative y is non-negative, then for x equals to square root of y, we have y is okay, so start with x squared plus 1 actually. So this is square root of y squared plus 1, and that would be y plus 1 is obviously greater than y. Yeah. So here you see that for any y actually, we can always find x such that x squared plus 1 is greater than y. Okay, so in other words, given y, we can find for every h such that the inequality is not correct. So in this case, we should say that this statement is false. Okay. Okay, so probably that's all for the first part of this tutorial. Now, for the next part, we'll start from number 4. Okay, so that would be the first part first.